Hi friends, welcome. We are so close to the end here. I wanted to go through I called it a practice test, but the sample questions that College Board just released for tomorrow. Okay, so this is the sample question 1. They're general notes here, and it'd be good if you were to read through these. I hope that you are not just watching this video, that you preferably have already attempted these questions, but at minimum that you are working these with me, because just watching is a very passive action. You're going to get a lot more out of it if you've already worked it, or at least you're working it with me, okay? So if we scroll down here, we've got question 1. I'm going to work this, okay? And then it says notes on 2020 exam question 2. The time allotted for 2020 question 2 is 15 minutes plus 5 minutes to submit. Most FRQs on traditional year AP Calculus AP B exams are designed to take approximately that much time. You are encouraged to practice both FRQ 4 and 6 from the 2019 AP Calculus exam. So that's what I'm going to do after I work sample question 1, okay? And I know that you've been assigned, these questions before, but I just want to take some time to kind of walk through them together. Okay, so sample question 1. And just as a reminder, you are going to see a 30-minute timer, but remember that that's also 5 minutes to submit. So as soon as you see that timer turn red, and it will turn red when you've got 5 minutes left, that's when you need to start taking pictures and uploading. And as a reminder, be sure that today you practice one more time how to upload your pictures. Go to cb.org/AP-demo. Okay, and just practice uploading and submitting pictures there. Okay, so the velocity of a particle P is moving along the x-axis, and it's given by a differentiable function v sub p of t, where v sub p of t is measured in meters per hour, and t is measured in hours. Selected values of v sub p of t are shown in the table above. Particle P is at the origin at time t equals 0. Again, please don't let that subscript of the p throw you off. They're just trying to be descriptive about which particle here, okay? So part A, justify why there must be at least one time for t between 0.3 and 2.8 at which v prime of t, so justify a derivative, I'm thinking this is mvt, the acceleration of the particle P equals 0 meters per hour, or meters per hour squared. All right, so this is definitely mvt. So if I look at the average rate of change between 0.3 and 2.8, so if I find the slope here, I would have 55 minus 55 all over 2.5. Well, 55 over 55 is definitely 0, so that's going to check for me. Now, if that interval didn't work, I can always check a sub-interval. Like then I would maybe check that interval and see if that worked. But in this case, the given interval works, so it didn't say is there, it just said justify, so by MVT. And the conditions for MVT are both differentiable and continuous. They tell us that v sub p of t is differentiable. So since v sub p is differentiable, v sub p is also continuous, and then we're going to show the math. So v sub p of 2.8 minus v sub p of 0.3 over 2.8 minus 0.3 was 55 minus 55 over 2.5, which equals 0. And we're done. You've got your 3 points. What theorem you used, why you can use it, and show the math. Okay? Alrighty, let's take a look at B. It says use a trapezoidal sum with 3 subintervals. And they're telling us the subintervals there. It's the same ones on the table. To approximate the integral from 0 to 2.8 of v sub p of t dt. Notice we're not going all the way to 4. So I'm going to go 0 to 0.3 is an interval of 0.3. 0.3 to 1.7 is going to be a change of 1.4, and then 1.7 to 2.8 will be a change of 1.1, okay? So first base is 0.3, and then the height, since I'm using trapezoid, is going to be the average of 0 and 55. Plus second base is 1.4. The height will be the average of 55 and negative 29. And then the last base will be 1.1, and the height's going to be the average of negative 29 and 55. And we're going to leave it like that, correct? All right, continuing on here, it's like a totally different question, but we're calling it part C of the same question. Anyway, the continuous function f is defined on the closed interval negative 6 to 5. The figure above shows a portion of the graph of f consisting of two line segments and a quarter circle centered at the point 5, 3. So this is the center, so the radius here we know is 3, okay? It is known that the point 3, 3 minus square root of 5 is on the graph of f. Okay, so part C. If the integral from negative 6 to 5 of f of x dx is 7, find the value of the integral from negative 6 to negative 2 of f of x dx. Show the work that leads to your answer. All right, so for part C, well, the integral from negative 6 to 5, this is one way to write it, is going to be the integral from negative 6 to negative 2, what we're looking for, plus, if I pick up the integral from negative 2 to 5, right? And this part was given as 7. This is what we're trying to find, and how can I find this? I can find area under the curve of that graph, right? So that's how we're going to set it up. So I've got 7 equals this piece I'm trying to find, the integral from negative 6 to negative 2 of f of x dx, plus, and now let's go take a look at the area here. All right, so I can slice this up lots of ways, but I'm going to kind of look at what cancels here, because look, I've got this area above the x-axis, this triangle, and then that same area below. So those are going to go away, okay? And then do you see you have kind of the same thing here? You've got this triangle below the x-axis, and then that same area above. So those are going to cancel as well. So really, I'm going to break it into these pieces. I've got that square, which is an area of 1. And then I've got this triangle, which is also an area of 1. And then I've got this weird looking shape, which is going to be this square minus that quarter circle. Okay, so I've got that 1 plus 1, that's 2. And then that square has an area of 9, minusing out that quarter circle. Well, remember we said the circle has radius 3. So the full circle would be 9 pi. So the quarter circle will be 9 pi minus 4. All right, so just to clean this up a little bit, I've got 7 equals the integral from negative 6 to negative 2 of f of x dx, plus 11 minus 9 pi over 4. So the integral that I'm looking for is equal to 7 minus 11 plus 9 pi over 4. I'm just bringing those two terms over, and that's equal to the integral I'm looking for. Okay? All right, part D, evaluate the definite integral from 3 to 5 of 2 f prime of x plus 4 dx. Remember, two ways to find a definite integral, what we just did, area under the curve, or antiderivative, and evaluate. So in this case, I'm going to take the antiderivative term by term, which is 2 f of x plus 4x. You can also break this up if you prefer, either way. I'm going to evaluate that at x equals 5 and x equals 3. So this gets me 2 times f of 5 plus 4 times 5 is 20, minus 2 times f of 3 plus 4 times 3 is 12. Almost done. So what is f of 5? Well, this is the graph of f of x, right? So f of 5 is 0. And then what is f of 3? That was given here, right? So f of 3 is 3 minus square root of 5. And I'm just keeping all the rest. So there is my final answer. Alrighty? Okay, make this a little smaller. No, that didn't work. Okay, part E. We are asked to find, we're given this new function, g, given by the integral from -2 to x of f of t dt. Find the absolute min on the interval -2 to 5. So absolute on an interval, we are guaranteed absolute min and max on a closed interval for a continuous function, which g certainly is. And whenever you see integrals like this, remember I want you to take the derivative of both sides. So the derivative of the left side is going to be g prime, and the derivative of the right side, I'm just going to replace t with x. So that'll be f, g prime of x equals f of x, right? And kind of if I just pause this problem for a bit, I do want to, we had one like this on the second mock that there are some questions on. So if I had like g of x equals the integral from -2 to 3x squared of f of t dt, and I want to find the derivative of both sides here, it's very similar. So you're still going to replace t with that, but now you've got an inside function, so be sure that you take the derivative of the inside function as well. Multiply there, you've got chain rule there, okay? So if here you've got something other than just x, make sure you apply chain rule, okay? You'll still replace this letter with that piece, but then multiply by the derivative of the inside there, okay? All right, so that was a pause on this question, but something I did want to cover. All right, so absolute max on a closed interval means we're going to make a table, correct? So I've got x, and I'm trying to find the max of g of x, which I like to put the formula here for my reference. Okay, so where can absolute mins and maxes occur on a closed interval? Well, either at the endpoints or any relative maxes in this case, okay? And a relative max of g is going to be where g prime changes from positive to negative, which only occurs once, only at -1. Some people like to put all the critical values, but I think it's worth our time to knock any out so we don't have to calculate all those areas, okay? So now I'm going to come fill in the table. So I'm going to fill any x in for this slot there, right? So for that first one, I'm going to have the integral from -2 to -2 of f of t dt. So notice I will not accumulate any area in that case, so that's just going to be 0. If I plug in -1, I'm going to get the integral from -2 to -1, so that's going to be that little triangle there, which will be positive 1/2. And then if I plug in 5 for x here, I get the integral from -2 to -5. But didn't we already find that up here, right? Wasn't that this, which eventually became that? So that is 11 minus 9 pi over 4, which is approximately 4, I believe, 3.931. So that's certainly our max, right? So our max, we can write it like this. G of 5 is equal to either 3.931 or that 11 minus 9 pi over 4. Okay? Justification is the table. All right. F, find the limit as x approaches 1 of this fraction here, this rational piece. So let's start by just plugging in 1 for everything. I've got 10 to the 1 minus 3 times f prime of 1 all over f of 1 minus arc tan of 1. 10 to the 1 is 10. F prime of 1, that would be the slope of the graph at 1, which looks like it's up 2 to the right 1, so 2. F of 1, if I look at the graph, is 1. Arctan of 1 means for what angle is tangent equal to 1. Look at the unit circle page I put it on your review sheet. That's pi over 4. That is certainly not 0 over 0, so I'm good. I'm done. Okay? All right, part G. Suppose that g of x is equal to this integral again. Is the rate of change in g increasing or decreasing at t equals 1? Explain. All right, so first of all, it says the rate of change in g. Well, the rate and change in g is g prime. So another way to ask this is g prime increasing or decreasing? That's what they're asking us at t equals 1, okay? Well, over here, remember we said that g prime of x is equal to f of x, correct? So we're asking, hey, is f increasing or decreasing at t equals 1? Well, take a look at your picture. It's certainly increasing, right? It's going up at 1. Now, that is not a calculus justification, okay? We cannot say, hey, look at this graph, it's going up. We have to talk about some kind of derivative, okay? So f is increasing there since its slope or its derivative is positive, okay? So g prime is increasing at t equals 1 since f prime of 1 is positive. The slope is positive of f, so that means f is increasing, and f is the rate of change in g, okay? Alrighty, so that was sample question 1. They said for question 2, study FRQ 4 and 6 from last year. So that is what we are gonna do now. All right, so here's question 4. A cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time t is modeled by dH dt equals -1/10 square root of h, where h is measured in feet and t is measured in seconds. The volume V of a cylinder with radius r and height h is given by V equals pi r squared h. Part A, find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. Okay, so we want to find dV dt, right? Find the rate of change of the volume with respect to time. So dV dt when h is 4, correct? Now notice they said the diameter was 2, so that means the radius is 1, and that's constant, so I can go ahead and plug that in. So I've got V equals pi r squared h. In other words, V equals pi h, correct? Okay, now let's take the derivative with respect to time, both sides of the equation. So dV dt is equal to pi dH dt, correct? Okay. Now we want to know this when h is 4. So let's come up here. So I've got pi times dH dt, which is this. Now when h is 4, I have -1/10 times square root of 4, which is 2. So -1/5 if you'd like, just to clean it up. So I've got pi times -1/5. So final answer, -pi over 5. Make sure you indicate units of measure. Notice it was dV dt, so volume would be in cubic feet, right? And then time was in seconds. And just for reference, this was worth 2. 1 for having pi dh dt, and then 1 for the answer with units. All right. Part B. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain. Okay, so I want to know, again, the rate of change of height with respect to time, that's dh dt. I want to know, is that increasing or decreasing? Well, if I want to figure out if something's increasing or decreasing at a moment in time, I need to take its derivative. So I want to know, is the rate of change, how is the rate of change changing? So I need the second derivative here. Okay, so we've got that dh dt is negative 1/10. I'm going to put h to the 1/2. Now I want to take the derivative with respect to time of both sides here. So I would get the second derivative with respect to time on the left side. Okay, here I'm going to fly that 1/2 over, so I get negative 1 over 20 h to the negative 1/2, now times the derivative of the inside dh dt, okay, or implicit differentiation if you want to think of it that way. We're deriving with respect to t, not h, so I need that dh dt at the end. Okay, now dh dt is that, let's plug some stuff in here. H, they said, was 3. dh dt is negative 1/10 square root of h, which again, h is 3. So it looks like here I'm getting a negative times a negative, so that's going to be a positive 1 over 200. And then I have like the square root of 3 over square root of 3 because of this piece, right? That's 1 over square root of 3, and those actually cancel. Not that you need to simplify any of that. It's fine to leave it here as long as you know that that's a positive number, right? So since the second derivative is positive, the rate of change of the height with respect to time is increasing. Okay? Alrighty. This is actually one I graded last year, and very, very few people actually found the second derivative. They just kind of plugged 3 into the first derivative and then said, oh, the rate of change is increasing. Well, if you plug into the first derivative, you're just finding if the height is increasing, and we want to know if the rate of change was increasing, so you need the second derivative in this case. All right, the last part, it says at time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So this is our separate and integrate, right, with the initial condition 0, 5. So I've rewritten the differential equation here. So let's separate. I'm going to move the square root of h, so it needs to end up in the denominator here. Remember, be so careful with this step. I'm going to keep the negative 1/10, but I am going to need to move the dt. Okay, so there's step 1, separate. Step 2 is going to be integrate, but before I do that, I am going to rewrite the left-hand side as h to the negative 1/2 dh. Now let's go ahead and integrate both sides. So for the left-hand side, let's bump the power up by 1, so that'll be positive 1/2. Now I want to divide by 1/2, which is the same as multiplying by 2. So there's the antiderivative for the left-hand side. Antiderivative for the right will just be negative 1/10 t. Now don't forget your plus c. If you don't put your plus c, no more points for you, okay? Now, as soon as you put your plus c, go find what your c is using the initial condition. So I've got 2 times 5 to the 1/2 equals negative 1/10 times 0 plus c. So I've got 2 square roots of 5. You could absolutely leave it as just 2 times 5 to the 1/2. That's totally fine. So there's c. So now that we've got c, let's come back to the first time we introduced c and plug it back in. And now we'll just solve for h. So divide everything by 2. And then square both sides. Final answer. Okay, this was worth 4. So 1 for separating, 1 for correct antiderivatives, 1 for the correct constant value, and then 1 for your final answer. Okay, and then let's look at question 6, which was also one I graded last year. So the functions f, g, and h are twice differentiable with g of 2 equals h of 2 equals 4. The line y equals 4 plus 2/3 times the quantity x minus 2 is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. And you may be more comfortable with seeing it in point slope form, right? Same thing. So part A, find h prime of 2. Well, h prime of 2 is the slope of the tangent line of h at 2, which they said this was the tangent line, right? So that slope is 2/3. Okay, that was worth 1 point. All right, I'm putting this for reference. Okay, part B, let a be the function given by 3x squared times h of x. Write an expression for a prime, then find a prime of 2. So a prime of x, I need product rule, right? So derive the first, hold the second, plus hold the first, derive the second. Okay, and that was worth 1 point right there. And then we wanted to find a prime of 2. So 9 times 2 squared times h of 2 plus 3 times, times 2 cubed times h prime of 2. Having issues here. Okay, so this I can keep. H of 2, they told me at the top was 4. And h prime of 2, that was part A, that was 2/3. Now, if, let's say, you blanked on part A, put something down, put pi, put 5, put 1,000, whatever, so that you can put something in for part B, okay? Make something up, because as long as that is equal to that, they're not going to penalize you, double penalize you, okay? You wouldn't get part A right, but at least you could get full points for part B still, okay? And again, let's leave it like so. All right, part C. The function h satisfies h of x equals x squared minus 4 all over 1 minus f of x cubed. For all x other than 2, it's known that the limit as x approaches 2 of h can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 of h to find f of 2 and f prime of 2. Show the work that leads to your answer. Okay, so a couple notes here. Since h is differentiable, h is also continuous, right? So in other words, the limit as x approaches 2 of h of x has to be equal to h of 2, which is 4. Okay. Also, since L'Hopital's rule applies, then when I plug in 2 for h of x here to top and bottom, I should get 0 over 0, right? Which I certainly get for the numerator. So I should also have, if I plug in 2 to the denominator, here's the denominator, that should also be 0. And I can put that 2 in for f because I know that f is continuous, okay? So the limit as x approaches 2 of f is equal to f of 2. In other words, if I solve this for f of 2 must be 1. Okay, so there, I did that. All right, now let's go ahead and apply L'Hopital's rule. So let's say limit as x approaches 2. If I take the derivative of the numerator, I get 2x. And then if I take the derivative of the denominator, that 1's going to go away. Don't drop the negative. Now I need chain rule, so I have minus, fly the 3, hold the inside, drop the power, then times the derivative of the inside, right? Chain rule. Okay. And that is supposed to equal, what do you remember? 4. Okay. So let's plug in 2. So I've got 4 in the numerator. Then I've got negative 3 times f of 2 squared. Well, f of 2 was 1. Okay, so 1 squared times f prime of 2, and that's what I'm looking for, okay? And that's equal to 4. So lots of ways you can solve this. You want to cross multiply. I would get 4 is equal to negative 12 times f prime of 2. So f prime of 2 is negative 4/12, also known as negative 1/3. Okay, and I did that. And we definitely showed all our work, so we're good there. All right, last part. It's known that g is less than h for all x's between 1 and 3. Let k be a function satisfying g of x is less than or equal to k of x is less than or equal to h of x for x's between 1 and 3. Is k continuous at x equals 2? Justify. Well, again, to justify continuity, we need to show that the limit as x approaches 2 of k of x is equal to k of 2. If we get that those are the same, we're good. And this is honestly kind of an intuitive question. If these are all, this is squeeze theorem, so if these are all squeezed together and g and h have the same function value and limit, then k must as well. This was only worth 1 point. You don't have to state squeeze theorem here. I'm not going to in my justification, but what I do want to state is that since, and we kind of stated this earlier, but since g and h are differentiable, g and h are continuous. In other words, the limit as x approaches 2 of g of x is equal to g of 2, which was equal to 4, and the same thing for h. Okay, all right, so let's take this piece here. That's what we're going to use twice. And we're looking at x equals 2, which is certainly in our interval. So let's just plug in 2 for each x there. Okay, so that's going to give me g of 2 is less than or equal to k of 2 is less than or equal to h of 2. Well, h of 2 and g of 2 were both 4, so if k of 2 is between 4 and 4, k of 2 must be 4. Okay, now let's do the same thing with the limits. So I'm going to take this inequality again and just put the limit as x approaches 2 for each of them. So I've got the limit as x approaches 2 of g of x has to be less than or equal to the limit as x approaches 2 for k of x, has to be less than or equal to the limit as x approaches 2 of h of x. Well, again, that was 4, this limit was 4, and this limit was 4. So the limit I'm trying to find, this guy, is between 4 and 4, so the limit as x approaches 2 of k of x is also 4. So is k continuous? Yes, since k of 2 equals the limit as x approaches 2 of k of x, and they're both 4. Done and done. Okay, All right, thanks so much for working these with me. Again, make sure you go practice submitting one more time today so that you feel really confident in the submission process. Again, that's cb.org/apdemo. I recommend using OneDrive to practice a submission. Now, just so you know, I don't get any of those submissions, so any work you want me to see, be sure you submit to Canvas. I am so proud of all the work you've done, even in these crazy times. And as always, don't hesitate to let me know if you've got any questions. And I will see you all at noon tomorrow on Zoom. We'll go over some last minute stuff, and then you will start logging in to the testing site at 12:30. Okay? Lots of love to you all. I'll see you tomorrow. Bye.